Okay, so now that we know what are the components of a robot, it's also nice to know what are the system-wide breakdown, or what is the system-wide breakdown of robotics. So these are all the ingredients that a roboticist should know at whenever he's designing or he's involved in making robots. Uh, and also, if you go from a top to down, the level of complexity increases. For example, kinematics and dynamics mainly pertain to how the robot moves. It's mainly a study of making the robot move, whereas the controls and the motion planning are much higher level, and they basically entail the fine tuning of these movements to ensure that things work properly. And then finally, you have your high level intelligence. So all the examples that I've shown you in the previous slides, right? All these robots will have machine learning, systems inbuilt that act as higher level intelligence. So the things highlighted in blue, right? These are the activities that you will be getting familiar with in this course. So for example, you will study kinematics of robots, and that'll help you to understand how robots move, and that is like the first step that anyone would need to know. Then you would also learn a little bit about perception. You would know what sensors are to be used in what scenarios, and how to take data from these sensors. And you will culminate in making your own obstacle avoidance algorithm, which falls under the whole broad umbrella of motion planning. So motion planning, it basically entails like navigation, obstacle avoidance. It's a huge module, but you'll be primarily working on a simpler component, which is obstacle avoidance. Depending on the availability and time, we might delve into control theory and a bit more things in motion planning itself, but we'll see. Okay, so some of the prerequisites that you might need to know while entering the field of robotics would include mathematics and programming. This is an advice not restricted to robotics, but I would say in any field in engineering. I would say the better you are equipped with these two tools, the better you'll be in terms of your technical skills as an engineer. One thing that I forgot to mention here was your IoT skills as well. So when you're working on actual robots, you would need to know how the electronics operates. You would need to know how the motors work. So, it's like an Internet of Things. But we'll probably be sticking to robotic simulators. This is not much of a concern. Okay. So yeah, coming to robotic simulators, why use simulators in the first place? If we have a robot, why not use the robot itself? Well, there are a few advantages of using simulators. One particular thing is suppose you're developing an algorithm. Suppose you're developing a machine learning algorithm that makes a humanoid robot walk, like the Boston Dynamics robot. You would not want to test your algorithm on the actual thing without knowing its complete behavior. So these simulators provide a way to test algorithms. It provides an inexpensive way. You wouldn't want your robot to crash and fall. You wouldn't want your UAV to hit a wall or something right off the bat. So that is perhaps the key use of these simulators. And another use would be to in scenarios like this, when we don't have access to hardware, it provides that we can get familiar with robotics as well. People in top labs like in Clemson University and Hong Kong University, they all use these simulators to test out their UAVs as well. So there is an application to these simulators. So for the purposes of this series, we'll be sticking to this thing called VREP. I chose VREP because this is it's simple to use. You don't need to know Linux or anything. Okay, so at this point, do you guys have any questions? Okay, Arnab asks, is it a path following robot? Well, yeah, I would also would want you guys to implement obstacle avoidance in addition to path planning, path following. So path following might be like a first step, uh, and obstacle avoidance would be like a bigger step in the whole motion planning thing. So for example, if you look at this slide, uh, so motion planning, I would say, constitutes a small part of, sorry, obstacle avoidance constitutes a small part of motion planning, which is itself a larger module which involves navigation, control, etc. I don't know any other coding other than Java basics. Oh, okay, okay, that's a very good question. And yes, you should be able to. I will even help. I'll guide you through the way. So we have sort of set this up in a way that we would have undergrads do one sort of assignment and high schoolers do another. Uh, for next week's assignment, I wasn't really thinking of having high schoolers do the two-armed kinematics model using Python. But if you'd like to do that, if you'd like to learn Python also in greater detail, I can help you out. I can help you build the code itself. Uh, so in next week's lesson, in addition to making the VREP script using Python, I'll also give you like a rundown on how to do it. So it'll be easy for all of you guys. Yeah, so like I was saying, all I would want you guys to do is follow these instructions, and your sort of assignment would be to describe what sensors are being used in the above simulation. And you should also tell me like what is the use of these sensors. So I'll just quickly show you how it looks like. You can follow this link to download VREP. So I'll just quickly start the simulation.
So there's a question saying, is it an online or offline software? What they probably mean is it going to be continuously connected to the internet to use?
Okay, yeah, good question. It's an offline thing, so you won't need to be connected to the internet. But yeah, if you're like working with multiple terminals like I am with Linux, you would probably need to have both terminals open. But it's an offline software. You don't need the internet to use the software at all. Yeah, I hope that answers your question. Yeah. Okay, so this is how the scene looks like. So each environment in VREP is called a scene. Right now, it's just an empty scene containing a floor. Uh, so what I would want you guys to do is just go here, click on File, click on Open Scene, click on this thing called Epoch Demo. So Epoch is a ground robot. It's quite a famous ground robot that is used in like research settings. Uh, So yeah, I think one of the first obstacle avoidance stuff was written on this. I'm not sure of the history, but yeah. So when you click on open scene, this is what pops up. So you can see the little robot here, and you can see like a line, like hit play, and just tell me the list of sensors and all that. Just tell me what is going on in what are the different components of the robot uh, that are playing a role here, and yeah, that's pretty much it. What we'll do next week is start understanding how to make these robots move. We'll understand what kinematics actually means, and we'll also make your own robot move in VREP. You'll also learn a bit of Python scripting that involves making this robot to move. Yeah, and I'll also probably have an assignment for you guys to do in Python, which would involve kinematics itself on a two-armed robot. Yeah. So that's basically my plan for next week. And with that, yeah, you, I guess we can have time for questions and.
That was pretty cool. Sharat. I'm sure the learners are excited to install VREP and then try the simulation of this robot and try to understand, okay, what is it doing and all that, and also become familiar on their first step to kind of mastering robotics. So yeah, I think this was pretty cool.
Yeah. So, like I said, right, it depends on your feedback as well. If you guys end up doing this relatively quickly, we can move on to more complex stuff. Maybe I can even throw in some control theory or motion planning towards the end, and you can have like a full navigation software, and that'll be like another building block.
That sounds very exciting. That brings us to an end for this session, right? And we're all looking forward to the next session and to get our hands dirty on using the simulator and trying to create a line following robot, understanding the theory behind things and all that.